escape velocity. Escape velocity. When we throw up a body, it comes back to the earth. As we throw up with greater velocity, the height attained by the body increases. So, there will be a velocity for which the body will not return to the earth. It will go on. It will cross the gravitational field. Such a velocity given to a body is known as escape velocity. The velocity required to leave the gravitational field is the escape velocity. This escape velocity will have a minimum value. Beyond that value, for all velocities, it will escape. That minimum velocity is known as escape velocity. It is defined as the minimum velocity required for an object, to escape from the gravitational influence of a planet. To escape from the gravitational influence of a planet is known as escape velocity. It is denoted by the symbol VE. The kinetic energy of such a body is half m v square. Gravitational potential energy. The relation for gravitational potential energy is Pe is equal to minus gmm by r, g capital M small m by r. Pe is equal to minus of gmm by r. G is universal gravitational constant. Capital M is mass of the earth. Small m is mass of a body. And capital R is the radius of the earth. And this value is the potential energy near the surface of the earth. In fact, this relation can be applied to any planet. It is defined as the amount of work done in bringing a body of mass m from infinity to a point near the earth. The amount of work done in bringing a body of mass small m from infinity to a point near the earth. Gravitational potential energy of earth and of the object system, we call sometimes this as the potential energy of earth object system, earth mass system. So the relation is minus gmm by r. Since the body is bound to the earth by the attractive force, this energy will be taken as negative. The energy due to attractive force is taken as negative, hence we get the negative sign. P is equal to minus gmm by r. Gravitational potential. We define this as the potential energy, the gravitational potential energy of a body of unit mass. It is defined as the gravitational potential energy of unit mass is taken as gravitational potential. Hence, the relation for gravitational potential V is equal to minus G capital M by R minus G capital M by capital R, where M is mass of earth, R is radius of the earth. Gravitational potential energy of earth mass system. Gravitational potential energy of earth mass system or the gravitational potential energy of a body of mass small m will be equal to V into small m. Hence, the potential energy will be equal to V into small m, which becomes equal to minus gmm by r. Relation for escape velocity. If we consider a body of mass small m near the surface of the earth, and by giving a minimum velocity Ve, if it just escapes the gravitational field, then its kinetic energy is half mv square. Half mv square is the kinetic energy required for a body to leave the gravitational field. Since the body is bound to the earth by a gravitational potential energy, the potential energy of a body of mass m due to gravitational attraction is P is equal to minus gmm by r. By considering the magnitude, we will get P is equal to gmm by r. gmm by r. The kinetic energy of the body should be equal to this gravitational potential energy in order to escape from the gravitational field. In order to escape from the gravitational field, the amount of kinetic energy required will be equal to the potential energy of the body. Hence, half small m v square is equal to half small m v square is equal to g capital M small m by capital R, g mm by r, which implies v is equal to square root of 2 g capital M by capital R, 2 capital G capital M by capital R, implies v is equal to square root of 2 g r. v is equal to square root of 2 small g r. We have the relation half mv square is equal to g capital M small m by r. Small m gets cancelled, hence we will get v square is equal to, hence we get v square is equal to 2 capital G capital M by capital R, from which we get v is equal to square root of 2 g m by r. v is equal to square root of 2 g m by r. We know that small g is equal to capital G capital M by r square. Hence, by substituting g m by capital R, capital G capital M by capital R is equal to small g capital R, we will get v is equal to square root of 2 small g into r, square root of 2 g r. Effect of escape velocity. Its value on the surface of the earth is 11.2 kilometers per second. Its value near the surface of the earth is 11.2 kilometers per second. The value will be different on different planets. If the RMS velocity of gas molecules on the surface of any planet, if the RMS velocity of the gas molecules on the surface of a planet is greater than the escape velocity, then the gas molecules will escape from the planet. They escape into the outer space from the planet. There is no atmosphere on the surface of the moon. There is no atmosphere on the surface of moon because the RMS velocity of gas molecules is more than the escape velocity on moon. The RMS velocity of gas molecules is more than the escape velocity on moon. The RMS velocity of gas molecules is more than the escape velocity on moon. Hence, the gas molecules escape from the surface of the moon. Hence, there is no atmosphere on the surface of the moon. Orbital velocity. Orbital velocity. The horizontal velocity required for an object. The horizontal velocity required for an object to revolve around a planet. To revolve around a planet in a circular orbit is called orbital velocity. The condition required for orbital velocity is centrifugal force is equal to gravitational force of attraction. The condition required for a body to revolve around a planet is centrifugal force is equal to gravitational force of attraction. Consider a body of mass small m revolving in circular orbit around a planet with a velocity v0 at a height h from the surface of the planet. Let r be the radius of the planet and capital M its mass. The body can be in circular orbit when its centrifugal force is equal to gravitational force of attraction. When it is in circular orbit, it is acted on by two forces. One is gravitational force of attraction pulls the body towards the center. The other one is centrifugal force which pulls the body away from the center. When these two forces are equal, then the body revolves in circular orbit. So, the condition required for circular orbit is centrifugal centrifugal force is equal to gravitational force of attraction. We know that the gravitational force of attraction is given by capital G, capital M, small m divided by r square, where r is the radius of the orbit. The radius of the orbit small r is equal to capital R plus h, where capital R is the radius of the planet and small h is the height of the orbit from the surface of the planet. So small r represents the radius of the orbit. The centrifugal force is given by mv0 square by r. When orbital velocity is v0, then the centrifugal force is mv0 square by r. The condition for orbit is centrifugal force is equal to gravitational force of attraction. Therefore, mv0 square by r is equal to capital G, capital M, small m divided by r square, gmm by r square. mv0 square by r is equal to gmm by r square. Cancelling small m and one small r, we will get v0 square is equal to capital G, capital M by small r. v0 square is equal to gm by r, or v0 is equal to square root of gm by r. The relation for orbital velocity is v0 is equal to root gm by r. The orbital velocity near the surface of the earth is obtained to be 7.8 kilometers per second. Orbital velocity near the surface of the earth is 7.8 kilometers per second. The relation between orbital velocity and escape velocity. The relation between orbital velocity and escape velocity. Near the surface of the earth, escape velocity Ve is equal to, near the surface of the earth, escape velocity Ve is equal to square root of 2gm by r, and orbital velocity is v0 is equal to square root of gm by r, in both cases capital R, which represents the radius of the earth. V is square root of 2gm by r and v0 is square root of 2gm by r. Therefore, V is equal to square root of 2gm by r, that is equal to root 2 into square root of gm by r. So, V is equal to root 2 times v0. V is equal to root 2 times v0. This is the relation between orbital velocity and escape velocity. Geostationary satellite. The artificial satellite that revolves in the same direction of rotation of the earth. The artificial satellite that revolves in the same direction of rotation of the earth with the same period of earth is called geostationary satellite. So, a satellite which revolves with the same period and in the same direction of rotation of the earth is called geostationary satellite. A geostationary satellite appears to be stationary for an observer on the ground. A geostationary satellite appears to be stationary for an observer on the ground. The height of the geostationary satellite above the earth is 36,000 kilometers. Its height is 36,000 kilometers from the surface of the earth, and the radius of the geostationary orbit is 42,000 kilometers. Radius is 42,000 kilometers, height is 36,000 kilometers. The period of geostationary satellite is 24 hours. The period of rotation of geostationary satellite is 24 hours. Uses of geostationary satellites. 1. It is used to study the upper layers of the atmosphere. Geostationary satellites are used to study the upper layers of the atmosphere. It is used to forecast the changes in the atmosphere. To estimate the shape and size of earth. To identify the mineral deposits inside the earth and on the surface of the earth, to identify the mineral deposits inside the earth and on the surface. It is used to transmit TV programs to distant places, to study the properties of transmission of radio waves in the upper layers of atmosphere, and finally to undertake space research.